So the base will come and attack this carbon. Attacking means giving carbon. So attacking means it is helping out that carbon, not destroying that carbon. So it will come and attack the carbon, meaning it will come and give its electron into the orbital of this carbon. So this is the site at which first reaction will occur. This is important to identify, otherwise your product is going to be wrong. So this base is going to come and attack this carbon. What are you going to get next? This is what you're going to get, fine. Now this both oxide ion is going to pressurize this carbon to eliminate one of the hydride ion from here. So this hydride ion comes out as H minus. This carbon develops a plus charge. This C plus and this O minus develops a bond. And if you rotate this bond by 90 degree, it will look like this. Fine. Here is your hydride. It can't wait for too long. It can't stay here for more than a nanosecond or a picosecond. This hydride ion is going to attack. Now it will not attack other molecules because nearby there is a C double bond O. And this molecule have a solvent effect, the caging of solvent. And two molecules are separated by a membrane of solvent. So penetrating that membrane and attacking other molecule is far more difficult. This hydride ion will attack this carbonyl group itself. So when this is being attacked, then you develop a negative charge on oxygen and a hydrogen will come here. And as I told you, this alkoxide ion will abstract hydrogen from water and become a neutral alcohol. And if you protonate, then this will become a carboxylic acid, otherwise it will remain carboxylate ion. So this is what you are going to get. If you protonate it further, then this is the acid that you are going to get. This acid is called mandelic acid. Not very important, but if you know, if it's better. This acid is mandelic acid. Alright. And let's solve one more last problem in this Cannizzaro reaction, and then we will solve that conversion problem that we have left behind. We'll revisit it, solve it, and then suppose we have this, and I have given conc KOH. Now you have to work out the product on yourself. This time there is no hydrogen to be loosed by one of the carbonyl group. If there is no hydrogen, then obviously what is there, that will have to come out because there is no other option. So try to work this out on yourself. I tell you, you'll feel a lot more happy that you're doing something in your life. You're listening to lectures, you're solving it, you're learning, you're growing, you are living a prosperous life. That will give you a very, very good feeling once your answer matches with mine. That will bring you on the top of this world and will fill you with new energy, and you will do well in all other subjects. Fine, so work this problem on your own and then listen any further. So I hope now you have worked out the problem, and then let's start discussing this problem. You have conc KOH here. This KOH, conc in concentrated form, can act as a nucleophile. So this is a symmetrical molecule. It will come and attack any one of it. So let me attack on this carbonyl. When carbonyl is attacked, the bond, pi bond, goes into the orbital of oxygen. So what you get out of it is this OH. Again, a base will abstract hydrogen from this OH. This is what it becomes. Now this O minus and O minus is pushing carbon from both the sides, and carbon is in a great amount of stress. But carbon can't bear this great amount of stress. So carbon will break one of its bond. When carbon breaks one of its bond, what it will do, which bond can it break? Either it can break this bond or it can break this bond. Now when it breaks this bond, carbon C minus will have a negative charge on it, and that negative charge will be repulsed by the lone pair of oxygen. So that's not a good option. If this group comes out, then it comes out as pH minus. When it comes out as pH minus, carbon develops a plus charge. C plus O minus forms a bond among themselves. So what we will have is this. pH minus comes out. pH minus, when it comes out, it will search for a site where it can put its electron into. And that site is this C double bond O. When pH minus attacks this C double bond O, then this is what we get. Simple. So, and as we have discussed before, this O minus will turn into OH. So this is an anionic form of benzylic acid. This is called benzyl. B-E-N-Z-I-L. Know this because this will reappear somewhere in the course. This is benzyl. And if you protonate this with hydrogen, this is benzylic acid. So this is benzylic acid conversion. Fine. So if you understand the basic, I mean, what can act as a nucleophile, which groups will leave out, when it leaves out, where it can go, what happens. As you can see, and as I have been repeatedly saying you, like reactions are nothing but electronic exchange, and just you have to start thinking that which is electron rich site, which is electron deficient site, how the reaction will proceed, which group will leave out, where the charge will go, what effect will operate. That basic thing we have studied already. There's no new concept coming in. We are just capitalizing on that concept and studying new reactions. There's no new concepts appearing if you observe. Fine. So be vigilant when you see a reaction, take your time and try to work out the mechanism on your own. When you do that, then no problem will seem to be difficult to you. Everything will seem very obvious, very natural, very intuitive. So if the examiner does a twist, you will not be bogged down by that twist. You will survive.